Okay, Algebra 1. So far in our study of quadratics, we've had two different forms for the quadratic and how to graph them, intercept and vertex. So again, intercept form, f of x equals a, x minus p, x minus q. Shock of all shocks, you can look at that and tell the x-intercepts right away. The x-intercepts are points, p0 and q0. Okay. The axis of symmetry, so if I look at, those x-intercepts, is going to be halfway in the middle of that. So it's the average of those 2 points. So x equals p plus q over 2. That is my axis of symmetry. It's halfway between p and q. The vertex, well, if this is my axis of symmetry, the vertex lives on the axis of symmetry. So the x-coordinate of the vertex is p plus q over 2, and then you just have to plug that number in to the function to get the y value. The direction of opening, A is positive, this guy opens up. A is negative, this guy opens down. Vertex form. So I should be able to look at this and tell you the vertex. The vertex is HK. The axis of symmetry is x equal h. To find the direction of opening, same thing. A is greater than 0, it opens up. A is less than 0, it opens down. Okay. To find the y-intercept, all you have to do is just set x equal to 0. Now, the final form we're going to learn is standard form. So these are people like these forms because they're in a special format. One format tells you the intercept, one format tells you the vertex. Standard form is f of x equal ax squared plus bx plus c. This is probably people's least favorite, but it's probably the most frequently occurring. Okay, nothing special has happened to put it in a form to tell you something. Okay, so if I look at this, think about it first. What would be the transformation that would take this function and turn it into this function? What would happen? Ax squared plus bx, and then ax squared plus bx plus c. The only difference is that plus c. So what would happen here is it just moves up, or down the value of c. So remember, with any function, if I add 5, it goes up 5. Subtract 5, it goes down 5. So I look at the graph, that's what's going to happen there. So does the c value have any effect on the vertex or axis of symmetry? So if I think about this, the value of c is going to move this guy up or down. Okay, so if I've got a graph, ax squared, something like this, the c value is just going to move it up or down. Okay, so what effect does it have on the vertex or the axis of symmetry? Well, it's not going to move me left or right. Okay, so it's not going to change the axis of symmetry. So no change on the axis of symmetry. But if I move it up or down, the vertex is going to move, the y value. So the y value of the vertex can change, okay? So look at ax squared plus bx. Set y equal to 0 to find the x-intercept. So if I set y equal to 0 here, I would get 0 equals ax squared plus bx. Factor this out. 0 equals, factor out an x, ax plus b. So when would this be equal to 0? So x is equal to 0. Or if ax plus b is equal to 0, then x equals negative b over 2a. So in solving that equation, I know that when I see this, x equal negative b over 2a, it tells me that's one of the x-intercepts of this guy right here. And small mistake there, it's not 2a, it's a, negative b over a, okay? So I know the x-intercepts are at 0, and whatever this is, negative b over a. If those are my x-intercepts, where would the vertex be? Well, we know the vertex and the axis of symmetry would be what, halfway between. So 1, 2, 3, 4, 5. So that would be right here, okay? So it would be half of this distance. So half of that distance is negative b over 2a. So that's where the axis of symmetry is going to be. So all of that to say, that's how I'm going to find the axis of symmetry. Okay, so to find the axis of symmetry, it's halfway between the x-intercepts. So the equation of the axis of symmetry is going to be x equal negative b over 2a. Well, if that's the axis of symmetry, that's also the x-coordinate of the vertex. And then how do you find the y-coordinate of the vertex? You're just going to need to plug that value into the function. So negative b over 2a. Okay. Now, this looks confusing, but let's just take a look at it. Here is the standard form of a quadratic. ax squared plus bx plus c. You just have to know this. The axis of symmetry is the line x equal negative b over 2a. If that's the axis of symmetry, it's also the x value of the vertex. If you know the x value of the vertex, you plug it in to find the y value. So to find the vertex, you plug in x equal negative b over 2a. Now the y-intercept is about the easiest thing in this form. You find a y-intercept by setting x equal to 0. In this equation, what would happen if x was 0? You'll be left with c. So the y-intercept is 0c. And then the same thing, a is positive, graph opens upward. A is negative, the graph opens downward. So if I look at this on a graph, here's standard form, ax squared plus bx plus c. So if you look at this one, a is negative. So as it gets more and more negative, it gets skinnier and skinnier. When a goes positive, then I see that the parabola opens upward when a is positive, okay? And what about the value of c? Remember, c is just the y-intercept. So when c goes up and down, that y-intercept moves up and down. Now, because I'm moving the y-intercept, it's also changing the x-intercepts and the y value of the vertex. Notice the x value of the vertex is not changing. There's no left and right movement here. So it's only going up and down. A little bit harder to see, but what happens when b changes? So remember, negative b over 2a is your vertex, so it's changing my vertex and my axis of symmetry. The only thing that's not changing is the y-intercept, okay? So the x-intercept is changing, but the y-intercept remains the same, okay? Now, let's get a little bit of practice with this one. So the value of a, changing a, you know that when a is positive, it opens up, and when a is negative, graph opens down. The value of b, so as I move the b, remember it was changing the, it changes, it changes the vertex, the axis of symmetry, and also the x-intercepts. The value of c is just my y-intercept, so it just moves the guy up and down, okay? Now, let's take a practice. F of x is negative x squared plus 4x minus 5. This is in standard form, okay? So I've got f of x equals minus x squared plus 4x plus 5. So in this one, a is negative 1, b is 4, c is 5. This parabola will open downward, because A is -1. So find the axis of symmetry. So that's just -b over 2a. So x equals -b over 2 times a. This is 2. So x equal 2 is the axis of symmetry. Now to find the vertex lives on that line. And I know that the vertex has to have an x value of 2. So I've got f of x equals -x squared plus 4x plus, what was it, 5? -x squared plus 4x plus 5. So I know that the x coordinate is 2. So f of 2 is -2 squared plus 8 plus 5. So this is 9. F of 2 equals 9. So the vertex is the point 2, 9. The vertex is 2, 9. So that tells me it is right here. Now, what do I know about the y-intercept? The y-intercept is what you get when x equals 0. So f of x equals -x squared plus 4x plus 5. If x is 0, y is 5. So 0, 5 is my y-intercept. So if that's the point right there, there's a matching point right here. So keep in mind, remember our pattern. Normally I would go over 1, up 1, but because this has a -1x squared, I'm going to go over 1, down 1, over 1, down 1, over 2, down 4, okay, over 3, down 8, okay. So I can get matching points right there, and now I know how to graph this guy. As with all of these, the domain is -∞ to infinity. The range, your y values start at -∞, and the highest y value you have there is a y value of 9. Okay. 2x squared plus 8x minus 2. So a is 2, b is 8, c is -2. This parabola will open upward because a is positive. Axis of symmetry, x equal -b over 2a. So this is -8 over 4, -2. So -2 is my axis of symmetry. Y-intercept. When x is 0, your y-intercept is at -2. So 0, -2, that means there is a matching point right there. Now, to find the vertex, you know the x value of the vertex is -2. So it's 2, 8, minus 2. So f of x equals 2x squared plus 8x, what was it, minus 2. So the vertex is going to be when x is -2. So you get 2, -2 squared plus 8, -2 minus 2. So this is 8 minus 16 minus 2. So this is what, -10. So -2, -10 is my vertex. So -2, -10 is right here. Now, according to the pattern of how I graph this guy, normally with x squared, I go over 1, up 1. This is going to be over 1, up 2. So over 1, up 2. Over 2, instead of up 4, you go up 8. That's how I got that point. So right here. And there we go. The domain of this guy is -∞ to infinity. And then the range is what? -10 to infinity. The trajectory of a water fountain A is given by this function in standard form. And the trajectory from B is represented by this table of values. Okay. So compare the vertex of each function, which trajectory reaches a greater height. Okay. So if I look at the table of values, the y values go from 5 to 8 to 10, 8 to 5. So that's the highest value right there. It's 10. So I got to figure out what is the highest value here. Well, that's a parabola that opens downward, right? So when they say find the highest value, it's code word for find the vertex. So in this guy, it opens downward. The axis of symmetry is going to be x equals -b over 2a, which is just going to be 1. So the axis of symmetry is going to be at 1. And now to find the vertex, so -x squared plus, what was it, 2x plus 8. So this is my function. The x coordinate is going to be 1. So f of 1 is going to be -1 squared plus 2 plus 8. So this is going to be -1 plus 10, which is 9. So that vertex is going to be at 9 right there. Okay. So I can tell that the height, this one, the maximum height, is 9, and over here the max height is 10. So which of these reaches a greater height? So that would be fountain B. So again, all we're doing here is just using that standard form to decode, and I had to decode the vertex because if a parabola opens down, the highest point is the vertex. Parabola opens up, the lowest point is the vertex, okay? And that leads you up into homework for this particular section.